In this video, we're looking at the normal distribution. The normal distribution is a symmetrical bell-shaped distribution. So it forms this shape with the mean in the middle and exactly half of the data being more than the mean, half of the data being less than the mean. So it's a distribution. We use it for continuous data, and it's a symmetrical bell-shaped distribution. When we have the standard normal distribution, we have a mean, so the mean of 0, so the mean's in the middle, and the standard deviation of 1. So we call these our standardized scores. So we call them Z, our standardized scores. So we have within one standard deviation of the mean, we have 68% of the data. Within 2 standard deviations of the mean, we have around 95% of the data. And within 3 standard deviations of the mean, we have nearly all of the data, so more than 99.5% of the data. Sometimes we need to standardize the score, and we use the formula here. So Z is our standardized score. It tells us how many standard deviations the piece of data is away from the mean. So that's our standardized score, Z. X is the piece of data we're looking at, so the number we're looking at. So we take our number that we're looking at minus the mean, divide by the standard deviation, and that gives us our standardized score. Okay, here we've got a question. Given that X is distributed, so this squiggle means distributed, and the N means normally. So given that X is distributed normally, and the first number here is the mean, and the second number here is the variance. So given that X is distributed normally with a mean of 100, so a mean of 100, and a variance of 9, and a variance of 9 means the standard deviation is square root 9, so 3. Find the following probabilities. So the first one, the probability that X is bigger than 102. So we've got a normal distribution. In the middle we've got the mean, so 100. We've got 102, so just to the right of the 100, 102. And the probability that it's bigger, so it's all of the area to the right of 102, everything more than 102. Okay, so now we get our calculator, and we go menu, 7 for distributions, then we want normal cumulative distribution, so 2. We want our lower value, which is 102. For the upper value, we just want to pick a really big number. So something bigger than 4 standard deviations away from the mean. So a really big number, let's put 1,000. Then we put our standard deviation, which is 3. Our mean, which is 100. Press equals. And we get our probability out. So 0.252 to 3 significant figures. So 0.252 to 3 significant figures. Okay, next question. Now we want the probability that X is less than 96. So again, menu 7, normal cumulative distribution. This time the lower, we want to be a really small number. So if we put 0, the upper is 96, and our standard deviation is still 3, Our mean is still 100. Press equal, so we've got 0.0912. So 0.0912, and again to three significant figures. And the next question, between 94 and 99. So this time the lower is going to be 94, the upper 99. Standard deviation still 3, mean still 100. So we've got 0.347. 0.347 to three significant figures. Okay, same sort of question. This time we've got words. So the distribution of the weights of coffee in a jar is normally distributed with a mean, so a mean of 200 and a standard deviation of 6.1. Find the probability that the weight of coffee is more than 204. So we'll get the calculator again. So again, menu 7, 2 for the normal cumulative distribution. So more than 204. So 204 is going to be our lower value. Our upper value is going to be a really big number. So we'll put 1,000. Again, as long as it's more than 4 standard deviations away from the mean, then it should be okay. The standard deviation is 6.1 and the mean is 200. So we press equals and that gives us our probability of 0.256 to three significant figures. So we've got 0.256 to three significant figures. Okay, next question, less than 194. So 194 is going to be our lower value. No, it's not. So we're going to pick a really small number for the lower value. 194 is our upper value. And our standard deviation and mean are still the same. So that gives us a probability of 0.163. And the last question, between 190 and 202. So the lower is 190. The upper is 202. And that's a probability of 0.578. Okay, so this time we've got a variable y, normally distributed, and we've got a standard deviation of 12.6, and we're given some information that says the probability that y is less than 104 is 0.4. So this time we're going to use our inverse normal function. So 7 and 3 this time, inverse normal. So we need to know the area. So the probability that it's less than 104 is 0.4. So we've got a normal distribution. We've got a mean that we don't know. And we know the probability of it being less than 104. So less than 104, this bit here has got an area of 0.4. So we're in our inverse normal function. We know the area is 0.4. Now, we're going to be asked for the mean and the standard deviation. And we don't have both of these bits of data. So we're going to have to use the standard normal distribution. So we're going to use the standard normal. And that is a mean of 0 and a standard deviation of 1. So we're using the standard normal distribution. So we've got a standard deviation of 1, a mean of 0. We press equals. And this is our Z value. So we know it's minus 0.253 standard deviations away from the mean. So Z equals minus 0.253. And we're going to use the formula to convert from a standardized score back to our, well, to find our mean. We're going to use the formula to find the mean this time. So we know Z is minus 0.253. Our value was 104 minus the mean over the standard deviation, which was 12.6. So we're going to find out what the mean is. So we're going to multiply by 12.6 first. So we can use the calculator. Go menu 1, and then we'll have answer times by 12.6. So we've got minus 3.19 here. So minus 3.19 equals 104 minus the mean. So if I plus the mean to both sides, I have the mean minus 3.19 equals 104, and then plus 3.19 to both sides. And that will give us a mean of 107.19, and we'll just give that to 2 dp. Okay, another question. The heights of a group of people are normally distributed with a mean of 174. 10% of people have a height of more than 190 centimeters. So we've got a mean of 174, got 190 over here, so we've got 10% as the area more than 190, and we can also say that we've got 90% less than 190. So again, we're going to be using our inverse normal, and because we don't know the standard deviation, we're working out the standard deviation, we're going to use standardized scores. So Z equals X minus the mean over the standard deviation. So let's get the calculator. Menu 7, 3 for inverse normal. So we're going to have an area. We're going to go with 0.9. So all of the area up to 190, 0.9. And we're using standardized, the standard normal. So that's a standard deviation of 1 and a mean of 0. So we've got our standardized score, our Z, of 1.28. So Z equals 1.28. So we're going to put what we know into the formula and find the standard deviation. So we've got 1.28 equals our value, which was 190, minus the mean, which is 174, over standard deviation. So if we times both sides by standard deviation, 1.28 times standard deviation equals 16, and divide both sides by 1.28, so we'll have 16 over our answer, and that'll be our standard deviation. So we'll get the calculator. Menu 1, we want 16 over answer, and that gives us 12.5 to 3 significant figures. So we can write that in, 12.5 to 3SF. Okay, this time we've got a variable x is normally distributed, and given the probability of it being less than 81 is 0.4. So the probability of less than 81 is 0.4. The probability of more than 92, so we've got 92 up here somewhere, more than 92 is 0.25. So we could also say the probability that it's less than 92 is 0.75. So we're going to use standardized scores and the inverse normal distribution. So it's menu 7, 3. So for 81, the area is 0.4. And we're using standardized scores. So the standard deviation is 1. The mean is 0. So for 81, the Z is minus 0.253. And what I'll do is I will store that in the calculator as A. And we're going to do the same thing for the 92. So we're in 7, 3 again. This time I'm going to use area as 0.75. And we get a Z score of 0.674. I'll store that as B. So 0.674. Okay, now I'm going to do two equations using our standardized score formula. So for the 81, we've got minus 0.253 equals 81 minus the mean over standard deviation. And if I multiply both sides by standard deviation, I'll get minus 0.253 standard deviation equals 81 minus the mean. And I'll plus the mean to both sides and plus 0.253 standard deviation to both sides. So if I plus mean to both sides, we'll have the mean on the left side, and if I plus 0.253 standard deviation to both sides, I'll get the mean is equal to 81 plus 0.253 standard deviation. And I'll do the same thing for the other one. So we've got a Z of 0.674. That's equal to 92 minus the mean over standard deviation. So I'm going to multiply both sides by standard deviation. Plus the mean to both sides. And this time I'm going to take away 0.674 standard deviation. So I've got two equations. They're both equal to the mean. So I've got mean equals 81 plus this, and mean equals 92 minus this. So what I'm going to do is I'm going to make them equal to each other. So I'm going to say 81 plus 0.253 standard deviation is equal to 92 minus 0.674 standard deviation. I'm going to plus 0.674 standard deviation to both sides. So I'm going to have my negative A value plus my B value for my calculator. So this is negative A because A is minus 0.253. So if I grab the calculator, so if I times A by minus 1, there we go. So I've got 0.253, and I want to plus on my B value. So plus B, and that gives me 0.928. So I've got 0.928 standard deviation, and I've got 81 plus that equals 92. So I'm going to take away 81 from both sides, which will be 11. 92 minus 81 is 11. And then to get the standard deviation, I'm going to do 11 over 0.928. So 11 over answer, and that gives me 11.9 to three significant figures. So now I want to find the mean. So the mean is either of these two formulas. So I've got 81 plus 0.253 times 11.9. So 0.253 is minus A from the calculator. So that will be 81 minus A times the answer. And that gives me 84.0 to three significant figures. Okay, one more question, same thing. So we've got the times of runs are normally distributed. And this time we've got 17% of the runners finishing the race in less than 22 minutes. So we've got 22 minutes here, and we've got 17%. 12% of the runners finished the race in more than 35 minutes. So we've got 35 minutes up here. And that's 12%. So that means less than, so I'll make a note of that, less than in less than 35 minutes, that will be 88%. And we're going to do the same thing we did last time. So we're going to use the standard normal distribution to find two equations with the mean and standard deviation in them. And then we're going to solve them to find out what the mean and standard deviation are. So we're going to get the calculator. We're in inverse normal. So we've got an area of 0.17 for the 22. And we're using the standard normal distribution, which means the standard deviation is 1 and the mean is 0. So we've got a z of minus 0.954. So z is minus 0.954. And we're going to do the same for the 35. So this time the area is 0.88. Standard deviation still 1, mean still 0. And we've got a z of 1.17. I should have stored them. So if I store the second one as B and store the first one as A. So now we're going to form our two equations. So for the 22, we've got minus 0.954 equals 22 minus the mean over standard deviation. And for the second one, we've got 1.17 equals 35 minus the mean over standard deviation. So I've rearranged them to both be mean equals. So if I multiply by standard deviation, and the same for the other one, then plus the mean to both sides. So plus the mean to both sides, and in this case plus 0.954 standard deviation. And for the green one, plus the mean to both sides and subtract 1.17 standard deviation. So I've got two equations equal to the mean, so I can make them equal to each other. So I want to have my minus A. I'm going to plus 1.17 standard deviation to both sides. So it's my negative A plus B. So I can do that in the calculator. Negative A plus B gives me 2.13. So I've got 2.13 standard deviation. So this added on to this side. I'm going to subtract 22 from both sides, which will give me 13. So standard deviation is 13 over 2.13. Again, I'll use the calculator. So that's 13 over answer, which is 6.11 to 3 significant figures. Okay, so there's my standard deviation. I'm going to substitute it in to find the mean. So if I use the red formula, so I've got 22 plus 0.954 times my answer. So that's 22 minus A times answer. And that's given me 27.8. So that's 27.8 to 3 significant figures.